It's 12 o'clock, so we'll get started. Thanks for taking the time today to join us, Interface H2O and Doug Buch with Pave Drain. We've been excited about what's been happening with Pave Drain over the last 5 years in the West Michigan area. And as things go towards the direction of infiltration, we feel that Pave Drain's a good solution to do that. The chat room chat will be open, and we'll monitor that as things kind of go. Doug and I's mic will be on, so feel free to ask questions while we're going on. And yeah, I'll let Doug introduce himself and take it away from here. And here we go, Doug.
James, thank you. James Smits and Interface H2O has been our distribution partner for, are we at 10 years already, I believe?
Close
to it. So it's been a very solid relationship since the start of it. And I started Pave Drain in 2008, right during, if anybody was in the working world then, you'll remember that was right as the world economy, US economy collapsed. Somehow persevered, and here we are today. So like any good PowerPoint presentation, let's start it off with a little video to get you up to speed.
Our cities are covered with impermeable surfaces. When it rains, rainwater has nowhere to go, except to sewer systems that struggle to handle the unprecedented strain. That's why we asked, what does your pavement do for you? Green technology has mostly failed to mitigate urban flooding and recharge aquifers. Green solutions look great on paper and may perform well at the start, but they disappoint quickly due to maintenance headaches, weak design, and their inability to handle intense rain events. The Pave Drain system solves these problems. For over 10 years, the Pave Drain system has proven effective for property owners looking to fix their drainage and paving challenges. The Pave Drain system is a simple yet unique solution that incorporates a patented arch design into large interlocking concrete blocks. The Pave Drain blocks are manufactured locally, available in several different colors, and are ADA compliant. When installed, gaps are left between the blocks for an unprecedented infiltration rate. Over time, debris will fill the joints, but maintenance is accomplished with vacuum trucks that remove the accumulated debris. Unlike other pavement systems, even when 75% clogged, the Pave Drain system still allows massive amounts of stormwater to infiltrate into the ground. With a properly designed and compacted open aggregate base, the Pave Drain system doesn't experience freeze or thaw heaving and can maintain its structure under extreme pressure. We also offer heated Pave Drain, which eliminates the need for salt. The heated system infiltrates melted snow back into the ground, preventing runoff, which won't become an ice liability for you or your neighbor. So think about it. What does your pavement do for you? Contact us today to see how we can help with your new or existing infrastructure challenges. And visit our website at www.pavedrain.com to see recent success stories. Pave Drain, the world-leading permeable paving system.
Fantastic. Sometimes I feel like after that video, I don't need to say anything, but James I'm contractually obligated to introduce you to Pave Drain a little further. So as we stated, the Pave Drain system was started in 2008. And our first large-scale project was at Ford Motor Company, where we installed about 90,000 square foot that is still in use today. In 2018, the plant was going through an expansion. So we went in, or the contractors went in, and they removed 15,000 square foot of Pave Drain, cut open a larger area in the old asphalt, dug a hole, lined it with the geotextile, filled it with the open graded aggregate, compacted it, and then reinstalled the 15,000 square foot of Pave Drain that had previously been installed in 2009. So quite this sustainable, reusable system that it is. Only maintenance has been done on this project has been completed by Pave Drain LLC. Ford Motor Company made the promise to the engineering firm that they would never do any maintenance work out there, and they've held true to that. But they've been a great partner for us, allowing us quite a bit of access out there to do some demo work and to test some of our theories and maintenance methodologies that we've really now believe we've come to perfected. But since that time, And when we really got going into the business, most of our business, I would call it 80-20, 80% of our business was with the private side of the United States. 20% was with the governmental municipalities. But since that time, it is really flip-flopped. About 80% of our business around the United States is all with the municipal market and municipalities as they gravitate towards a more green infrastructure and incorporating Pave Drain as a part of their traditional green and gray infrastructure, which we'll show you as we go through this. Michigan has been in the party for a while now. They have 28 and counting Pave Drain projects in the ground, over 225,000 square foot that has been installed since 2012. I believe there's about 3 projects estimated for 2022. And one of the big projects that we were involved with was the Keeler Street Detroit infiltration and maintenance study with Tetra Tech. And quite honestly, one of my favorite photos is the one in the lower right-hand corner of Grand Rapids doing the bucket dump onto the grand opening of Atlas Avenue in Grand Rapids, Michigan. What a great photo that is there. So what is Pave Drain? Just to really break this down, first thing we really like to talk about is what it's not, and it is not a paver. We do everything we can to differentiate ourselves from a paver. Pavers are tiny, pavers are small. Pave Drain blocks are big. That block there on the left weighs about 50 pounds, or the little paver on the right probably weighs anywhere from 3 to 5 pounds. So again, not a very big unit as compared to the Pave Drain system, Pave Drain block. So what Pave Drain is, it's a permeable articulated concrete block. Now the blocks themselves are not permeable. The permeability comes in the joints. We leave the joints and the gaps that surround the interlocking blocks, we leave them open. Each individual block, as you see there, measures 12 inches by 12 inches, 5.65 inches tall, and weighs in at about 48, 49 pounds, a little bit more than that in certain places where we get it made. Mostly in Wyoming, Michigan they make a heavy product there. Pave Drain system, it just does more. It paves, it drains, and it is maintainable. We're going to spend a significant amount of time talking about maintenance. Most of the green infrastructure world out there really wants to ignore it. We don't. It is a proven paving system, hence the name Pave Drain. This is a pavement that can drain. Manufacturing, being a bigger, heavy product, we need to make this a little closer to its jumping off spot. Consumers Block and on the western side of the state has made the vast majority of the jobs. Best Block on the east side of the state has also made some product, but we've manufactured Pave Drain in 40 different block plants all across the United States, and we own about 12 of the molds, and they all rotate, move, and ship all over the country to the different block manufacturing facilities to be contract manufactured by Pave Drain LLC. Vast majority of the jobs have some sort of hand placement on it. The rest of the jobs are installed by machine or machine lay, which you see here on the lower left-hand and right-hand side of the project. And this is a project in Ada, Michigan, showing blocks being installed. This is a layer of 11, so 11 square feet, 4 by 3 by 4. Getting pulled over, driven over, and dropped into place. And you'll see them dropping it onto a biaxial geogrid, dropping it into place, and he goes back and gets another one. So that 11 square foot took about 20 some seconds for an experienced, skilled operator to drop those into place. One of the big differences between Pave Drain and the permeable pavers that are out there is the interlocking ability of the block, and the fact that we do not, I repeat, we do not need rock swept between the joints to keep them intact. Pavers are tiny. They don't really interlock together. What they need is that sand or rock swept or filled between the joints. And what that creates is an aggregate interlock to help them stay together. Unlike pavers, Pave Drain does not pre-clog our joints with that silt and sediment or that rock between it. We leave it open. We want water, as much water getting in as possible. Now we know over time, and we quickly recognize that is going to fill with debris, but this is a much easier methodology to clean and maintain this than to pre-sweep it and pre-clog those joints with rock or sand. All the corners are rounded. Snow edge is created to catch on a snowplow. Snowplows are kind of brutal on everything. Our blocks, these blocks will not be flipped up and knocked out of there. Can they be chipped? Can they be damaged by a steel snow blade? Absolutely. Steel snow blades on a big heavy dump truck, snow truck will easily scratch and chip concrete. We're really no different than that. But the blocks will not be flipped and kicked out of there like people have heard horror stories of the pavers that have happened. One of the things that we implemented in 2019 was to seal the pave drain blocks after they have been installed. Salt is a real issue. Salt's an issue with everything. I think if the general public knew just what salt was doing to their water supply and everything else, it would be stopped even quicker than what it is. As you see, a lot of cities, states, counties moving more and more towards sand and removing the amounts of salt that are going in. So corrosive to it. But what we've started doing is adding in a salt inhibitor into our mix design. And then to top it off, once Pave Drain is installed, you can go back and seal it. Anything else that's in the permeable world, once it's installed and you went in and sealed it, you'd seal it off. With Pave Drain, that's not the case. You can go in and properly place these sticks. Each block is basically 1 square foot, and you put those sticks in, and you understand with a 5-gallon pail covering anywhere from 150 to 300 square foot, depending on your mix, you can properly apply the correct amount of sealant to the appropriate area of pave drain blocks. So pretty handy way of doing it. Our cross sections are pretty varied. The thinnest cross section we've ever done is about 2 inches on a pool deck. The thickest we've ever done, I believe, is about 10 feet. We are highly dependent on the woven monofilament or woven multi-filament geotextile that is beneath the rock that's placed directly onto the ground. That wraps up all 4 sides. The rock variations, we typically only have 2, a larger ASTM 5th size number 2 or 3 in the bottom, and then a ASTM number 57 stone, clean, angular on all sides, worked into the larger number 2 or 3 stones in a 2-inch lift, all of it compacted in lifts. And once you get the proper bedding layer, our bedding layer underneath the pave drain is the 57 stone. The geogrid, which you saw in the previous video, is then placed on top, and the pave drain is placed on top of that. It's proven a very effective way of building our cross sections. One of the first projects we were ever involved with was out in Bladensburg, Maryland, which is right outside of Washington, D.C. City of Bladensburg was tired of their continuous maintenance of their asphalt parking lot, constantly sealing, resealing, restriping. Every time you seal it, you got to go back in and restripe it. And we were fortunate enough to go in and replace this, one of our first early projects. Now, one of the things that happens during most construction projects is inclement weather. Pretty tough to control it. Unlike most other permeable systems, you're in trouble if the weather doesn't cooperate. Rumor has it doesn't always cooperate in Michigan and the upper Midwest. So this was installed in rain, sleet, snow outside of DC, and it was still allowed to go in. It's built for this type of stuff. So that project has now been in about 10 years. And we'll show you a little quick little video here of just how much water this takes on. You notice the fire truck has been driven right on top of the pave drain. And you'll see the video here where the a lot of permeable systems use a garden hose. We try to take it to a little bit next level and drive a fire truck right on that. And you'll see how fast it infiltrates. To accentuate that, and you talk about it even further in terms of infiltration rates, is a test comparison that was done out in Washington, D.C. by a regional stormwater management company called Exact Stormwater Management. And this is the video that they prepared for us, showing the differences between all the different videos. Now, one thing I want to point out is the dates that you're going to be seeing here.
Stormwater BMP installations, maintenance, and testing. I'm here today in Northwest DC, hired by Ernest Meyer to do some testing on porous pavers, porous asphalt, porous concrete, and pave drain.
Permanent pavers installed in summer 2014, test in April 2015. Sean uses a diffuser to spread the water out across the full 12-inch diameter tube that you see there, plexiglass tube. Pervious concrete installed in 2014, tested in April of 2015. So largely pre-wetting the area there. Asphalt 2014, tested 2015. And then the pave drain. You'll notice we were installed a year ahead of everybody else. And look at what Sean is standing on, our tree canopy. We were not real pleased with this because of being really how we got treated versus everything else.
Four systems today. The porous pavers that we started with, we got 3.2 inches per hour infiltration rate. Then we went to porous concrete. We got 2.4 inches per hour. We went to porous asphalt. We got 3.1 inches per hour. And we're here at the pave drain, and we got 1,640 inches per hour infiltration rate. This is all according to ASTM C1701.
And again, that's not a typo. Those are real numbers and real data that came out of that from them. Now we have our own pave drain storage and infiltration calculator. We also have a new one online that has been out for about 6 months now on different ways of infiltrating through different types of soils, which is becoming a real intriguing thing as engineers are pushed to install permeable systems in tighter and tighter soils, i.e. clay type soils that are out there. We also have AutoCAD on top of AutoCAD, much easier to edit than it is to create, and we can help you out in that category as well. And some of the new stuff that we've been getting into is more and more underground detention. I'm sure everybody recognizes chamber units underneath this. Pave drain, because it will decrease the amount of stormwater because it's permeable that you need to account for. Many times you can decrease your amount of underground detention that you are looking at underneath. Now, I really want to get into the maintenance advantages and really talk about this. This is the green infrastructure. The Achilles heel of it, as you see, has probably been the maintenance side. A lot of promises up front that just don't seem to be kept or met. And our massive infiltration is a tremendous start for us. Now, we've been a part of multiple studies all around the United States. One I want to point out is the city of Detroit, Michigan, the Tetra Tech study that is out there that's been done since, James, I'm forgetting the date off the top of my head. I think that's already 6 years old, 5 years old.
5 or 6 years old.
5 or 6 years old. So a lot of documented maintenance, low cost results of this. And we are more than happy to share all of this with you. One of our first ones was with the University of Louisville. Their Center for Infrastructure Research that was done. From there, we went down to the University of Florida. They take stormwater pretty seriously down there. They have a whole academy, a stormwater academy at the University of Central Florida in Orlando. And one of the things we want to point out is this picture right here with the pave drain vac head and the diabolical treatment that they give to these permeable systems down there, including pave drain. What they do is we installed a pretty good area of pave drain. I believe it was about a 60 by 40 area of pave drain that was installed. And they come in with a Bobcat bucket filled with dirt, silt, sand, and weeds and dump it on there. As if that isn't enough, they then come in and water it all in. And then their final step is they let it cook and bake in the hot Florida sun for a couple of weeks, then come back to the owners and say, hey, come clean this. And what we were able to do is hook this up to a combination sewer vac truck that's off in the background. And we utilized the pave drain vac head. And we were able to bring this back to 90+% of its original infiltration rate. Now that's based on those previous videos you saw. Let's say the original infiltration rate was over 1,800 inches per hour pre-STM C1701, meaning we'd usually bring this back to upwards of 1,600 inches per hour. So we're well above anything else. And what we're really doing when we're talking about these infiltration rates is playing a math game. If you start out at 1,800 inches, and the failure number is under 10 inches per hour, obviously probably going to take a little longer to get down to 10 if you start out a little higher than if you start out at 100 inches like pre-clogged pavers tend to do. So from there, after all those tests were done, the University of Louisville came back and did a pollutant removal test. We can give you these results on that. EPA came back and did a full test on really different types of maintenance that was done within a gray infrastructure. Here's a screenshot of the Tetra Tech study that was done at Keeler Street and Artisan Street in Detroit. Tremendous article on that. We can easily share that with everybody. What we really want to focus on is what was done in Louisville, because and some of this was done on Keeler Street too, just a little bit smaller scale. But what we're really doing here is combining, and what municipalities are doing are combining green infrastructure, i.e. paved drain, with traditional gray infrastructure, and what we're accomplishing with this. Now, this first project that we did in Louisville, Control 19H and 19G, had pretty high run-on ratios. A lot of permeable pavers and other permeable systems want very low run-on ratios, meaning 2, 3, sometimes as much as 5 square foot of traditional impervious surfaces, i.e. roofs, parking lots, traditional asphalt and concrete, running onto 1 square foot of the permeable surface. And the reason they want low run-on ratios is because of debris. They can't handle it. They clog too fast. These jobs here had much higher run-on ratios, 16-to-1 and 20-to-1 for these two little areas here, totaling about 1,300 square feet. Just a tremendous amount of debris was hitting this area. Now the question becomes, how does an owner effectively clean this? And this is what we were really tasked with doing. They looked at electronic measurements as a sample. We started off down a path, and this has gotten expanded upon the last couple of years. Visual inspections were a large part of it, but this is really what they were looking at, is it's time for maintenance, but how and will it be cost effective? Now, this picture here is what we want a lot of people to talk about. Most people would look at this and say, yep, clogged, probably not infiltrating. And the worst part about some of this green infrastructure, you don't know it's not working until it's too late, meaning it's already rained, it's already flooding out. Now we got problems. Now we got to go clean it. We can help overcome that hurdle. We looked at a lot of different types of ways of testing it and cleaning it. And the most effective way to clean it was with the pave drain vac head and a sewer vac truck. There's a little before and after. You can see the paint marks on there and see how effectively we got this clean. This is a great way of cleaning out troubled areas. Going down streets that have miles of pave drain in, which we do, this becomes a little bit unrealistic, and we needed equipment to be able to do that. And we shifted from that to more of what's called a Elgin Whirlwind or Megawind type pure vacuum trucks. The results on this were just terrific as well. So the bigger city streets, as I said, became what we really had to get going on. And this is a video showing an Elgin Whirlwind cleaning out a lot of organics here on Washington Street in Louisville, same place that we utilize the pave drain vac head on. A little pre-wetting here goes on. There's so much suction coming up out of this 2-inch by 18-inch wide port that the blocks actually rattle and move a little bit. Then we always got to do the gratuitous water dump test just to show that it is working. The Elgin Whirlwind was incredibly effective. Municipalities are moving in this direction just because of worker liability, safety, distracted drivers. This is probably a little bit safer way to get this clean than having workers outside of the trucks with a vac head. Now, the vac head in a very troubled area is still the way to go, but on big stretches of streets like we have in parts of the country, this is a great way of doing it. Kind of before and after. And then we even took a tape measure and dropped it down to show you we were going down the full depth of that to get this cleaned out. Tremendous amount of suction on those Elgin Whirlwinds. Froze up there for a second. Now I want to get a little more real world. Kind of interesting here. We were monitored, the University of Louisville was monitoring this with piezometers that were installed underneath us to really document what was going on underneath us, which gave us some ideas a little bit later down the line. They got a 7-hour rain event, which generated 2.26 inches of rain. Max intensity, as you see, was about 1.2 inches in 1 hour. This cross section, which here was almost 10 foot deep, was completely filled up with water and filled up the aggregate cross section. flushed out the joints of the paved drain, ran down the curb, and went into the gray infrastructure. It's a great example of gray and green infrastructure working hand in hand and working together. So the paved drain here was not clogged. It was just the cross section was filled up or was flooded with water. What's neat about this cleaned out the paved drain, flushed it out. No need to go back in because we don't pre-clog the joints. This just went back down and everything was good to go. So it's a self-cleaning paved drain on when you have an event of this size and scope. Red line represents cumulative surface runoff. Black line represents what was captured. And what you can see is even on the first year, that big storm event happened late. Early in the year, we hardly had any rain. End of the year, we had several big rain events, but only on about 1,500 square foot, we captured 250,000 gallons in 1 year. Now, if you're a municipality and you're trying to meet a consent decree, trying to meet an MS4, trying to eliminate and minimize some localized flooding, you can see just how much water you can infiltrate and capture in a paved drain system with minimal square footage strategically placed around your municipality or around your project. Gotta love Google Earth for these types of things. Our Louisville assembly plant here is a 10-to-1 drainage ratio, going back to Ford, back to one of our original projects that we were involved with. And what was neat about this is we were able to take that same Elgin whirlwind. Now, difference between the Louisville, downtown Louisville, and this was downtown Louisville. The first test we did was a lot of organics. This was not organics. This was mud, dirt that had been there for years. You can see we threw a set of keys down on a paved drain block there just to give you some idea of size and scope. Now, what we're doing is looking at the outer 3-4 feet of the paved drain in that parking lot. Go in another 2-3 feet from there, and that paved drain is pretty clean. But you can see just how much dirt and mud has been accumulated on here. This is nothing more than what's run off of the parking lot from all the other trucks and vehicles that are parked there on a weekly basis. Picture on the left shows Ford prior to cleaning it. You can see the joints are pretty jammed up. And then the picture on the lower right-hand corner is just one single pass going over that Elgin whirlwind, little pre-wetting, and it pulls a lot of that debris up and out of there. They had to go several passes to get it perfectly clean, but pretty easy work driving around in that truck like that. Well, we like to ask everybody here, what's missing in the holding tank if permeable pavers would have been installed? We'll answer that for you. One of the answers is a lot of debris like this, but a lot of all that rock. And that rock is what's expensive. Vacuuming it out beats up all that rock, beats up the fans on these trucks, and beats up the fans on any of these cleaning equipment. When you're just pulling out mud, dirt, debris, much easier on it. But the other expense is that now you're done with pave drain. Whereas with pavers, you have to go back in, repurchase the rock. And the big number is you got to go reinstall it and typically maybe shut down your parking lot again. So maintenance effectiveness, with all that we've done, all the research we've done around the United States, performance can easily be restored with pave drain. Nobody likes to do maintenance. We understand that, but things happen and things get kicked down the road. Pave drain's probably going to keep infiltrating water at some point in time, but eventually you might have to go get it clean. When you do, understand that we can get it back to basically brand new. Now, what started to become more of a question to us is, and everybody asks it, when to maintain it? How often do I maintain this? What we like to say to everybody is, would you ever replace a light bulb before it needs to be replaced? If they were doing some sort of, LED switch out all over a city. The answer to that is no. You don't replace a light bulb till it's burned out. Why do we want to maintain a permeable surface when it doesn't need to be maintained? The secondary question we started asking ourselves is just how much stormwater are we capturing? Because we were involved with project after project that engineers, owners are telling us, due to the modeling that was done, this should have flooded out, and we were still taking on more water and infiltrating it back down into the ground. So what we did is we aligned ourselves with a company, 3 PhDs out of the University of Marquette in Milwaukee. And these 3 PhDs had formed a company called P4 Infrastructure. And what we did with them is worked with them to develop what is called the Pave Drain Infill Tracker. Now, the Infill Tracker, you say, is a two-part system. The picture on the left and the upper picture is the actual battery unit. shaped like, they're both in the shape of a paved drain block. That's basically a concrete block unit, if you will, with a solar panel on it. Now that solar panel can be driven on, it can be scraped up to, I believe, 90% and it will still recharge that battery. It's inside of that. The picture on the lower left-hand corner or on the left is the actual float valve that is drilled down in between and down into the rock and installed. Why we wanted it done this way is we wanted to do post-installation installations. We did not want anything to be done pre or up front. What happens then is as that sensor is being moved up and down by the amount of water that's infiltrating and being captured, the float valve in beneath there is registering how much is going up. It sends a signal to a nearby cell tower or tipping rain bucket, rain gauge, and support post. The reason we put a tipping rain bucket on top of this is because just in case there's a water main break or something's a little funky or wonky, this can help tell us that, yeah, there's no rain going on here, or there is rain, and it's all the measurements are in the same readings. The Infiltracker then sends this message off to your computer screen to tell you what is going on beneath your permeable beneath the paved drain system. One of the things I'd like to point out, one of our first good-sized jobs we ever did this on was a project called Van Norman Alleyway in Cudahy, Wisconsin. We have all of the documentation on that, but you can see the dates here. So this was January 20th of 2020. And it warmed up just a little bit. And look at what we got here. We got snow melt running off of there, draining into this and doing this. Another thing I'd like to point out is this reading here on March 10th of 2020. This is the actual job site. This is what the paved drain actually looked like. Now to you, me, layperson looking at that, they'd say, yeah, those joints look filled with debris. We probably need to clean that. The documentation after a rain event said, we're still infiltrating tremendous amounts of water and we don't need to clean it just yet. So this is a documented way for when to really go clean it, as you could compare different storm events that occurred over a same type period. You could then determine more accurately when it and effectively when it needs to be maintained. Now, what we know is that these systems tend to clog from up gradient to down gradient. It's going to happen that way. We've seen it over and over again. I don't think this is going to surprise anybody, but we've actually can let it go to this level. The picture on the lower left-hand corner is a picture from right outside of Indianapolis, Indiana. They let it go 6 years on this little area here. Now it had a tremendous tree canopy over the top of it, and they just kind of let it go. You can see actually a little chia drain being generated right here. And it just wasn't working to the level that it was when it first went in. Big shock there. It had never been maintained in 6 years. And then the crew down there, city crew down there, with the help of our distribution partner in Indianapolis, went back in with a paved drain backhead, and they effectively cleaned this, brought it back to brand new. And here's what you have again. Now, what we've been able to do is we'll show you a little cross section here, and we've taken this to even further levels that are going in around the country. What's going on here is a cross section showing just how much water can be captured and infiltrated here. A lot of municipalities and engineering firms have under drains built right into this, but the under drains don't do a whole lot of good if the infiltration rate doesn't really occur. If you have an under drain and it just drains right through the paved drain, through the open graded rock, into the under drain, and right into a manhole or into traditional gray infrastructure. What we've been able to do in this project here is P4 has developed a real-time control valve, or an RTC valve, on the end of the Infiltracker. This valve can be controlled by the depth of the float valve that's in here. Gets within 2, 3, 4 inches of beneath the paved drain. This can send a signal. This float valve can open up, releasing some of the water. Once it gets to a certain level, that float valve can then send another signal. We're down low enough, shut it off, and get full infiltration into the system, maximizing your traditional gray infrastructure. We have full details available on all this. This particular project here that we're working on in, I believe this one is in Lincoln, there is no under drain, there is nothing. They just want to measure just how much water is being captured. Very clayey soils on this project, and but they still know they're getting infiltration because they've been in for 1.5 years, and they've never had it overtop the paved drain, and it should have during several storm events. And then we can also get into what we just showed in the previous slide, where we can put in a RTC valve as well to control the flow and the amount of depth of water that's being captured and held in the beneath the pave drain. It's pretty interesting technology there. And P4 is the local, or excuse me, James Smith's, and Interface H2O is the local distribution partner of the infill tracker as well. It is not sold through Pave Drain. It is a part of our system, but James Smith's and Interface H2O sell that throughout Michigan. Now we want to get into a little sequencing. It's important. Sequence is important. I know it's tough to tell a contractor how to put something in, but we can make the case pretty easily that they want to put in the pave drain, curb and gutter first, which is not a sequence. And the pave drain really needs to go in because it makes it much easier to install the pave drain asphalt up against the pave drain, as you see here. We really don't like ribbon curbs. We do everything we can to stay away from ribbon curbs. Like pavers need it because they're so tiny and they need that ribbon curb, the concrete ribbon curb, to stay in place. Pave drain, because of the bulk and size of it, is its own ribbon curb, and it can withstand these pressures of these equipment going up next to it. We supply a lot of these blocks. So rather than cutting blocks to fit around these curves and around these things, it's so much easier for a contractor. Just put some expansion joint in, if you will, and pour concrete around this. The contractor that did this project said that he would have had a laborer out there cutting for 2, 3, 4 hours trying to cut blocks to fit around that. It never would have looked right, never would have fit right. And this is just almost exponentially easier and faster to have that done that way. Minimal block cutting is nice. It makes things easier for the contractor. Another city street, this one's called Brown Street down in Lafayette, Indiana. This goes on for, I believe, 6, 7 blocks on both sides of it. No ribbon curb again. Here's something interesting that happened out of this project. So this was bid head to head against traditional gray infrastructure. What the engineering firm and the contractor were able to eliminate, they were able to eliminate 20 inlets. And the reason pave drain is the inlet. So 20 inlets at $3,500 a piece. Storm pipe was eliminated, all the detention ponds. I think if you stood next to that city engineer, he'd tell you the asphalt deteriorates faster on traditional gray infrastructure. And how do we know that? Because there's a street about 3 blocks over that was built at the same time, does not have pave drain on it, and they've already had to go back and seal the asphalt. The green infrastructure, i.e. the pave drain here, was actually bid for $105,000 less than traditional infrastructure. It has been a rousing success, as we are now on, I believe, phase 5 or 6 of this project going in throughout West Lafayette and Lafayette. City streets are a little different, especially with concrete. There's a project in Milwaukee, and what we had the contractor do was over pour the city street by about 1 inch. City rules prohibit cutting of a gutter pan or a curb and gutter, mostly because a lot of them are old and they don't want to replace them. This is just happened to be a brand new one, but still held the same rules. So the contractor came in with a concrete saw, cut off about 1 inch of that, peeled it off, and cleanly and easily dropped the pave drain in between. What we were really trying to avoid is having big gaps there to fill with rock chips on the edges, and it created a nice snug fit and worked out really well for everybody. So Midwest projects, I believe this one's an Iowa full street project. You want to tell a landowner they can get rid of their detention ponds and put up another rack of storage sheds. So we're able to do on this project in Milwaukee. And this is a new school parking lot down in Missouri. Get a little closer to home in Michigan is Kalamazoo Valley Community College here. And then a beautiful mire up in Warren, Michigan, and James and the gang were able to catch this during a storm event, right after a storm event. You can see the backside of this mire has the water gushing out of off the roof, drains and onto the pave drain. Amway World Headquarters in Ada, beautiful brown mixed blocks there. And then another project in Wisconsin. This was quite the interesting project with the Wisconsin DNR and Wisconsin DOT. Going around this curve, they never cut a block. the pave drain has just enough articulation or accordion effect in it that they could go all the way around this curve and never cut a block. This particular project that we're showing on the upper right-hand corner is installed outside of Washington, D.C. And this is installed on a 7.5% slope on there. Now, full disclosure, those blocks are all solids on there, heavy duty, as we like to call them. They were not any of the arched units that were on that for fear of the slope and also the way the wheels can dig in on a slope like that. And this is a residential driveway right outside of Madison. And then some other projects, another one in Milwaukee. I think this one's in Milwaukee, and by state law, we have to show you Harley Davidson if we show too many from Wisconsin. And then a real neat photo of a sidewalk, National Arboretum in Washington, D.C. Sidewalks have become kind of all the rage in a few territories, Hawaii, Florida, Maryland. I cannot believe how many sidewalks we are now getting into. Colors, I don't know why that slide didn't pop up. Let's try one more time. Nope. Different color blocks that we do out there. Charcoal, gray is our most popular color. Charcoal is probably our second. The reds, tans, browns are getting up there. The blue blocks that you see here are the most expensive blocks we've ever made. Those are blues. Two colors that are really challenging to do are blue and green. They're really challenging to do. And I believe these blocks went for $50 per block. Everything had to be bought up front. So we were not taking the chance on that. And then a neat project not too far away from Michigan, Goshen, Indiana, which is now doing, I believe, their 5th job this year, is they held a sanctioned bicycle road race and drove it all the way across Jefferson Street, which is a block and a half of pave drain. And the riders felt no ill effects. So green pave drain blocks. Now we can spray, these are integral green all throughout it. We've also had municipalities that are getting to the point where they're going to paint it green and stain it green, which is way cheaper than us coloring it integrating throughout the whole thing. Logo blocks, great way to distinguish your project. These are not little pavers that nobody can read. These are big logos that you can put on there. And it's a great way to pay for a little project if you're getting into it. I want to also point out that these are ADA compliant as well. And with that, I will turn it over to James Smits with any follow-up questions or anything else that anybody has out there.
Thanks, Doug, for keeping us on track and time. Open the floor up to questions that you might have for Doug or I, with design questions or those sorts of things. You can chime in. We'll also be providing PDH credits to everybody that attended. And we can also send some links to you guys via email if you want design links and that sort of those sort of details.
Doug, James, this is Yuli Sala. I was the engineer for that Meyer building in Warren.
Yes,
I'm trying to remember. Yeah, I'm trying to remember when that was built. That was 17, I think. And I have yet to get a call of any issues or anything on that site. And that entire building, the whole roof runoff comes out to that back, we'll call it the alley or the back drive. And it has yet to reach the catch basins, I don't think.
It was designed properly, Julie.
Well, you guys did the design. I just said okay.
It's here's what we had right on that. We got the right geotextile. The rock, I believe, correct me if I'm wrong, was about 36 inches deep on that one.
It was, Doug.
Yes.
And compacted in lifts and geogrid put down, and that's what happens when it's done right. Tend to have those type of success stories with us. There's a question here that how long do the blocks last before they need full replacement? So I'll add, some of that depends on salt and what's going on with salt and snow plowing and damage. What's really unique about this is, again, this is a concrete blocks, 4,000 plus PSI. I believe the last report we got from consumers, it was over almost 6,000 PSI blocks. They're very, very hard. You may have a block that's going to break or chip or something's going to happen. You may have a spill of something that goes on top of that and you stain the blocks or something like that happens. You don't have to replace all of them. You just have to replace that area. It's very unique to Pave Drain is we have an extraction tool to go in and pop those bad blocks out or damaged blocks, whatever you want to call it, and the blocks can be replaced pretty easily. Really doesn't take a whole lot. And let's see, what else do we got? I hope that's, so we're anticipating that the blocks, the full replacement. So we're sitting at 2022. We've had jobs installed since 2009. It's getting up there. So I'm pushing for 25, 30 years. And some of that's going to depend on salt, damage, plows, all that type of stuff. But we're pushing for 25, 30 years is where we're at. And again, you may only have to replace a certain small area. How much oversight is a great question. How much oversight is needed to make sure it's done right? This is a fantastic question. Construction inspection materials like that. That's a great question. So what James Smith's and Interface H2O does with our contractors is they have what is called a pre-con before we even ship anything. And it's solved a lot of problems. We didn't used to do it early on. Some of the stuff that Daniel is pointing out here occurred because we didn't do that. Now we do it. The good thing is, and that you saw early on in the presentation, is we have 20 some projects already installed, 225,000 square feet. We got a lot of contractors, a lot of people are pretty familiar with it. So it's not nothing that is shockingly brand new. Generally, people kind of get it. We have YouTube videos out there that show what to do. If there's any issue that happens, it is the not compacting the open graded aggregate in lifts. The contracting community is a little mistaken in that you can't compact open graded aggregate, and yet we dump it in, run a vibratory compactor over it or big plate compactor over it, and it settles quite a bit. So that's the one thing that we've really had to fight and struggle to get through it. I hope I answered that question as well.
Can I add one thing in there, Doug?
Go.
One of the other components to that is over time is really paying attention or detail to your curb. That'll be the largest hang up because we all think that the curb guy is going to pour a straight curb, and then the landscape or block layer comes in and it's wavy, and that's an important challenge to address long before the curb's put in, because that'll make the guy who bid the project very angry when he's got to cut 60 extra 50-pound blocks.
We've gone into a lot of jobs, and the job I showed you in Lafayette, I'm not sure they cut 4 blocks on that whole entire job, and it was 60-some thousand square feet, which is great. It's got another question here from someone. Let's just call it down south. Clay soils. This is our and required subdrains. Now, one of the things you saw in the presentation was the under drain on the very bottom of the aggregate cross section. We have seen more and more engineers. We have details of this, of over drains, meaning the over drains are installed above, just below the paved drain, but well above the bottom of the aggregate cross section. Clay it won't drain, it can't drain, it doesn't drain. And what the infill tracker has proven to us and shown, because we installed an infill tracker on what could only be considered bathtub clay in Milwaukee. Every soil engineer, every geotech said this is bathtub clay, you'll never get it to drain. Yet somehow when we put an infill tracker in, lined it with a geotextile, filled with open graded or aggregate, and then let rainfall on it, the infill tracker proved out and showed that clay did in fact drain in 72 hours every time. And the more wet it got, the more it drained. Now, some expansion of clays down in like San Antonio and a couple other places. That might not be the case, but we've really gotten to the point now with what's going on with the Infiltracker to prove and show that clays most clays can take on some more water than anybody expects them to be able to do. Again, belt and suspenders, you can put it over drain in to just back it up a little bit as well. So another question is, are the vac trucks easily available or have these been a constraint for a project? The vac trucks, the pure vacuum trucks like the Elgin Whirlwind, Mega Wind, those are not as readily available around the country. But there's other just pure vacuum trucks. That Elgin's just one of the name brands. Timco makes another one as well. But the combination sewer vac trucks are everywhere. I see them. I mean, municipalities have them all over the place to clean out manholes, culverts, everything like that. I see them there everywhere we drive and everywhere we go. We see those combination sewer vac trucks everywhere. The Pave Drain vac head can easily be hooked up to a combination sewer truck. Great question there.
Hey, Doug.
Yeah.
So in the Grand Rapids market, we have a company called Santa Sweep, and many of us in the construction world will see them out on jobs when they're grinding asphalt and stuff and picking that up. And so for us in Grand Rapids in the West Michigan area, we would contract with them because they have the Mega Whirlwind, the high CFS to that vac area. So at least in Grand Rapids market, and I think in other markets, you can rent them, because they use them in the asphalt business when they're resurfacing.
Mr. Sala also from the designer of the Meyer and Warren, it was on clay soils and used 36 stone underneath it. It's still draining. So another question, I may have missed it, but can you elaborate how the snow melt works? One of the things that we showed during the brief video, we didn't touch on the snow melt system a lot, is Pave Drain can be manufactured with cable ducts within the blocks, meaning we can put the heat source real close to the surface, whether that be electric wiring or PEX tubing. What that does is makes it very efficient for melting of snow. So the blocks themselves, concrete thermal mass, heats up and it tends to melt that snow. Nice thing about Pave Drain, when it melts, it just goes right back down through the blocks into your open gated aggregate and back down. So you don't have to put a lot of you don't have to put any insulating courses beneath the paving system like you do with other snow melt systems. And we've installed multiple driveways. We haven't done a lot of streets or anything like that yet. We've done sidewalks, driveways around the country to do it. So
Helipads.
We've done about 8 helipads around the country as well. Infiltration calculator. The infiltration calculator is, go to pavedrain.com and you'll click around up across the top and it will not take long to find it. Ben, can you put that on there as well?
He did already.
Everybody. Okay, good job. Oh, Matt, look at me. All I got to do is scroll. Cost estimate, James, I'm going to leave that up to you.
Yeah, for the block itself, you're in that $7 a square foot range. All in, depending on your cross section, labor rates, those sorts of things, you're probably in that $15 square foot range.
Yep. Pave Drain generally gets delivered to the job site standard gray, James, for
$6.50 to $7.
$7.50. Yep, that's about right. Installations typically about they're about $2 a square foot. The rock depth every 6 to 8 inches is typically about $1, depending on what's going on.
The rock in West Michigan all comes from the dock, so it's pretty readily available. We start getting further east on the other side of Grand Rapids up towards Lansing, then it probably gets a little more challenging to get. But limestone angular rock is pretty readily available along the lakeshore here to truck in.
Oh, I got a question on lead time. I'd love to be able to answer this in Michigan. In Florida, it is I twitch every time somebody asks what's the lead time because of how long it's taking. But in Michigan, we're typically about 6 to 8 weeks from the time all the paperwork is signed and done, and we beat it most of the, we're on the low side of the 6. We got good producers in Michigan, and they know what they're doing. They know how to make it. When we get going in the year too, there's times we have inventory on the ground. Not a lot. 2,000-3,000 square foot is a lot of times sitting on the ground.
Those are all great questions. A lot of different questions for different aspects of the pave drain. Very much going forward.
Ooh, I just got a good question. Any
Yeah.
issues with maintaining utilities beneath the paved drain, such as a water main break? No, in fact, the stuff the stuff I showed with that we showed with the Lafayette and West Lafayette, that was their thing, was how could we do this? The truth of the matter is, popping out a paved drain block, getting paved drain blocks out, removing them. We provide an extraction tool as part of the bid package. I think we provided 6 of them for the job in the West Lafayette. So they had plenty of them around there. A paved drain block can be popped out of there in minutes. Once you get a bunch of them out, now you're talking dig out the area, go do your repairs just like you would normally do, fill it back in with the same rock if you have it, and the same paved drain can get put right back into place. It's kind of amazing that it can happen, but we've already done it. Nothing too extraordinary about it. Which is another reason why you might want an infil tracker on a lot of these jobs, because it can tell you that you've had a water main break before you know you had a water main break. Because that's another reason why we put the tipping rain bucket nearby. If the infil tracker valve is going skyrocketing, pushing up, or getting moved all over the place, and the tipping rain bucket is not telling us there's any rain, pretty good indicator something else is going on. Great question. By the way, Paul Harvey, we miss you. Wish you were back on the radio. That's the rest of the story.
Yeah, right.
Thank you. What a great way to close it out. And we do miss you. So,
Well, with
anything
that said,
else?
we're close to 12, Doug.
Great job. Thanks for setting this up to James Smits and Ben Ruby at Interface H2O. Look forward to working with anybody. Any questions you have to those two? They're well versed and well adept at answering anything.
Great. We'll
Thank you,
get
guys.
PDH. We'll get PDH credits out to everybody that attended. Yeah, feel free to give us a call or email us, and we can help you out however needed.
Great job. Thank you.
Thank you.